This video will demonstrate how to work with the fruit fly Drosophila melanogaster as a part of a long-term scientific experiment. You will conduct this lab over several weeks, compiling information along the way to complete the exercise at the end of the experiment. Before you receive your fruit fly, it's important to learn the life cycle of Drosophila. The timing of the life cycle stages is very important in conducting this experiment. Refer to the charts and the text in the lab or the internet to learn various stages of Drosophila life cycle. Eggs are laid shortly after mating and take only 1 day to hatch into larvae. Larvae go through 3 instar stages, taking approximately 2 days each. Pupae develop for approximately 6 days before hatching into the new adult fruit fly. It is also very important to be able to determine the sex of your fruit fly. Refer to the charts in the lab and your manual to learn males from females. Males are smaller, have rounded abdomens, fewer stripes, and sex combs present on the front 2 legs. Females are larger, have pointed abdomens, many stripes, and no sex combs on their front legs. Your professor will tell you how to get your file of flies. Your file will contain both male and female flies. This generation of flies is known as the F1. There is a label on your file with the number and the date when the culture was started and the place to write your name. Put your name on your file and transfer the date and number to the form in your lab manual. Use a dissecting microscope to look at your flies and differentiate between male and female. Next, see if your F1 flies have any mutations described by your professor. If they do, record if the mutation is found in just males or females. Now you have to wait and observe the life cycle of fruit flies as it happens. One or 2 days after you receive your flies, look for eggs on the surface and larvae actively feeding in the blue media. The next important date is when you first see pupae on the side of your file. Record that date in your lab manual. Pupae take about 6 days to develop into adults. On day 4 or 5, you must remove all original F1 flies from the file. It is very important that all the F1s are cleared out of the file before their offspring, the F2s, emerge from the pupae. To remove the F1s without harming the developing larvae and pupae, anesthetize them with cold temperatures. Place your file in the freezer upside down or on its side. Leave the F1s there for approximately 8 to 10 minutes. When you take your files out of the freezer, be very careful how you pick it up. Keep the files on its side or upside down. Do not hold it upright, or the anesthetized flies will fall and get stuck in the blue media. With the file still upside down, remove the foam plug and gently shake the immobile F1 flies into a petri dish. Replace the plug and return the F2 pupae and larvae to the incubator. Next, observe the F1 adults under stereo dissecting microscope to study males and females and confirm their phenotypes. Make sure you record the day you cleared F1 flies on your lab manual. The next important date is when the first F2 adults emerge in your file. This should occur 2 to 4 days after you cleared your F1s. When you first see the adult F2s in your file, record the date in your manual. Approximately 12 days after the first F2 emerged, it's time to conclude your experiment. You will clear your F2 flies using the same method that you used to clear your F1 flies, except you leave them in the freezer longer. Make sure you place your file on its side or upside down, and for F2s, leave it there for at least 30 minutes. When you remove your file from the freezer, remember not to hold it upright, or your flies will become stuck in the blue media. Always keep the file upside down or on its side. Remove the foam plug and observe the various combinations of phenotypes in your F2 flies. Your professor will give you instruction of best way to do this. Use the dissecting microscope to group flies with similar phenotypes and count their numbers. Ask a CLA or your professor if you need help. You should have a total of 60 to 150 flies. Be sure you record this information in your lab manual. Pay close attention to how your instructor tells you to turn in your files and flies. Your professor will also provide information to you on how to perform the chi-square test and form a hypothesis and prediction for your Drosophila experiment.